Hello, I wanted to start this broadcast today to let you know that I'll take just a few minutes to go over the handout that we didn't get a chance to go through today, but might be helpful for you as you study these concepts and answer the last portion of questions in homework assignment number 8. So if you'll pull out the yellow handout from today, what I'd like to do is walk through that with you. And I have it right here, and we'll take a look. And what you see on this handout packet, and if you have yours in front of you, you can take the notes right on the packet, is there are statistical tests that we've mentioned in which you do comparisons or differences. And at this point in the course, you should recognize that as t-tests and ANOVAs. And that's what is pictured here on the first. And as we scroll down, we can see the second page of the yellow handout that you've gotten today. The other kind of statistical questions that we can ask are, we can take a look at relationships or associations. And on pages 3 and flowing over to, I guess it's just the bottom of page 3, you will see there is some basic information about chi-square. And then at the very bottom of the page is some information on correlation, which we've reviewed to a pretty good extent. And I have another ancillary handout available for you on Moodle with regard to that. But for right now, let's just go back and let's take a look and just very, very quickly review the information here that is on the yellow handout. T-test, independent groups t-tests, the groups are not related. Dependent groups t-tests, the groups are matched on a variable or essentially are the same group pre and post. And with regard to these comparisons, you are saying, I've got a group here and I've got a group here. And if you follow my cursor, we're going to look at the mean in this group and we're going to look at the mean in this group and we're going to see if there are any significant differences. To run the independent t-test in SPSS, you enter the data. Here it's shown on table 5.6 on page 81 of the textbook. And the only exception is you're going to use only 1 and 2 as opposed to 1, 2s, and 3s to indicate the two different groups. So what's nice is you guys don't have to worry about this. You won't be entering the data into SPSS, but essentially SPSS is going to run for you the comparison between what is the mean in group A and what is the mean in group B. So when you get your SPSS output, your eyes will immediately focus in on this p-value. And the way that SPSS is going to figure this p-value is SPSS is going to compute the t-value. And I showed you today in lecture what the formula is for that. You don't need to know it. And the t-value, we have to figure out if that t-value is high enough or if the absolute value of the t is high enough, because t can actually be negative or positive, to be statistically significant. And that's going to depend on the degrees of freedom, or essentially how many subjects you have in your test. If the absolute value of t is high enough to be statistically significant, and that will be determined by SPSS, you simply look at the p-value. And if the p is less than 0.05, this t-value is not likely to have been due to chance if the null is correct. Remember that the null was stating that there was no differences. So if p is less than 0.05, this t-value is kind of extreme, all right? It wouldn't have been due to chance. It wouldn't have been due to the normal variability due to sampling. So we say that, in fact, something happened. We're going to reject the null. That's our, if you want to label this portion of the handout, this is the decision you make. You're going to reject the null and you're going to accept or retain the alternative hypothesis. And then you're going to have to write a conclusion. And I really like for people to write a complete conclusion. Generally, if you find that there is statistical significance, you can say there is a statistically significant difference in the mean, and you could put strength or balance score between groups A and B in the instance where we had an independent t-test. In the case of a dependent t-test, and you end up with a p-value less than 0.05, you'd say there is a statistically significant difference in the means between pre and post. And what I like to hear as people do these interpretations, if the mean post was greater than pre, you should state that. And you can include that, in fact, in this sentence by saying there's a statistically significant higher mean in the group post-test as compared to pre-test. Okay? So you get the idea. Something is happening, and you need to come to a conclusion statement. This is your decision. This is your conclusion. Keep in mind, you have the possibility of falsely rejecting the null. That's a type 1 error. Falsely rejecting the null. You shouldn't have rejected the null. There's going to be a chance of 5 out of 100 had you set your p-value less than or equal to 0.05. If, on the other hand, the absolute value of the t that's computed by SPSS is not high enough to be statistically significant, that is, the p-value is greater than 0.05, all right, we're going to accept the null. We're going to say there are no significance in the differences in the strength between groups A and B, or there are no differences in the amount of muscle mass pre and post-testing with this particular supplement. Keep in mind, we could have made a boo-boo here as well. And when we falsely accept the null hypothesis, and we say nothing happened, there's a good chance that actually something did happen, in which case we would have made that type 2 error, The probability of the type 1 error is 0.05. We're not going to talk about probabilities of type 2 error. That's beyond the scope of this course. So now, you scroll down. The one-way ANOVA essentially do the same thing. Only in this case, your null hypothesis is there's no difference in the means. And you're going to test that statistically by entering this data into SPSS. We're going to enter the data in completely, just as it's shown in table 5.6, page 81. And what you're going to see is that SPSS is going to calculate that F value for you. Essentially, it's going to be looking at the variance between the groups relative to the variance within the groups and saying, hey man, there's enough going on here to really make these groups significantly different with regard to their mean. All you have to look at on the SPSS output is the p-value. Then with that p-value, you're going to make a difference to either reject or retain the null. In the instance where the p-value is less than 0.05, assuming that you set it at this level, we'll reject the null. We'll accept or retain the alternative hypothesis, and we will see, in fact, that there is a statistically significant difference in the mean strength among groups A, B, and C. But the problem is we don't know where that significant difference lies. In the case of an analysis of variance or an ANOVA test, you do multiple comparison tests after the fact to see, in fact, if the group differences between A and B are what made the F significant. Were the group differences between B and C what drove the significance? Or were the differences between groups A and C that drove the differences that we saw that made this a significant F value? So you guys get it. I'm hoping that you get it. You see here that if we end up with a p less than 0.05, it says somewhere in here there are mean differences that are significant. We don't know where. It could be multiple places where they're different, but only when we complete the multiple comparison tests, which are beyond the scope of this class, can you figure this out. Finally, if F is not high enough to be statistically significant, i.e. the output on SPSS shows that the p is greater than 0.05, we accept the null and we conclude that there are no significant differences. Just as in the t-test, we could have made an error in type 1 or type 2. A type 1 error is when we falsely reject the null. We say something is there, but really that's just the normal sampling error that can occur, much as like in our M&Ms question. We have a couple of instances where we can do statistical tests to show associationships or relationships. One of those tests is chi-square. You need to be familiar with the gist of this. I won't make you interpret this, but I do ask that you understand when we would use the chi-square test. The purpose is to determine if there's an association between the levels of one or more nominally scaled variables. So for instance, we might have the question, is there association between gender and the type of class you enroll in, using the example that came from the book? So we run the chi-square test by entering the data into SPSS as shown on page 76. We then hit crosstabs in SPSS. It's under the descriptive statistics options. And what we see is that we're going to end up with a chi-square value. SPSS will determine what is the p-value. If the p is less than 0.05, we reject the null and accept the alternative hypothesis. We will then, in those kind of cases, say there is a statistically significant association between gender and what class you chose, okay? And then if there is a p greater than 0.05, we're going to say there was no significant association between gender and classes that you chose. So down here on the bottom, you're going to see the last kind of test that we might do in this particular class. Again, it's another example of looking at an association or relationship. And what the null hypothesis is that there is no relationship between the variables. The alternative hypothesis says, yes, that correlation, that rho value, okay, it's not zero. It's something else. So you need to turn to a final handout that I have. It's not covered very well in your book, and review the testing for significance of the Pearson product moment correlation coefficient. And I think it's a good example of kind of walking you through how those tests are done. Any questions? Please let me know. Thank you.